Hey, this is a funny little story. Something I just uploaded to GitHub that I hadn't seen in, over 2 decades. It's a couple of routines that I had written when I was a teenager and uploaded to a programming BBS. Now, I had lost these routines, with all the 5¼ inch floppies I had and all the early experiments that I had in programming in Turbo C and the games I was writing. They're all gone. But this survived because I had uploaded it. And so it's kind of funny to see it again. I thought it would be interesting to kind of have people look at it, and especially the old README that I had written, how I had described what the routines did. And what they were for is that it was a BIOS interrupt replacement, which you need to do if you're writing a game. The get ch routine that you read about in the Turbo C manuals, that isn't going to get you anywhere if you want to be reading more than one key at a time, or if you really want tight control over things like knowing how long someone has held a key, because all you get is the character that the person pressed, and then there's a delay, and then the key repeat. So I explain all of that. I thought it was funny to see it, and also interesting to think that I've been involved in open source a lot longer than I thought, and just that idea that I had written it and then wanted to share it. One of the things I provided was a test program, and I thought I'd fire up a Windows virtual machine to show the test. And you can see here's the key test program that mini keys on, so that does the BIOS replacement. And before you exit the program, you have to do mini keys off because you have to put the interrupt back. It has a couple of features related to remembering if a key has been pressed, even if you didn't pull it, so that if you just happen to miss that someone hit escape, you can tell how many times it had been hit. It's kind of fun. And this is just a routine that uses the key string array provided to get the key name. If you look at the numbers that are used underneath the BIOS layer, it's not like 65 for A. The keyboard has its own internal numbering scheme. And so, for instance, escape is 1 because escape is in the upper left-hand corner of the keyboard. And so funny stuff to learn about when you're a kid, and it's all a mystery to you. And so I wanted to share it, but I also I don't want to keep all this crap around so the test program, you can hold down keys and it can show you its detection. Now, it's interesting to note that the wiring inside the keyboard or underneath the BIOS is such that not all key combinations will work. And in fact, it kind of, screws up, especially on this Bluetooth keyboard, going through to a virtual machine. I mean, I'm surprised it works at all, but it still does. So here I'm going to press the A key and hold it down. And now I'm going to release it. And now I'm going to press the A key again. But before I release the A key, I'm going to press the S key. And I'm going to release the A key. And I release the S key. All right. And so, Windows has, key down, key up, that kind of thing. And then there's also a different layer where you can get the characters. But DOS didn't have that. You had to actually replace the interrupt. And so we can see kind of how far it can go. I mean, I get to the point where I'm almost running out of fingers. So A, S, D, F, holding them all down still, G, H, J, oop. And at this layer here, or whatever we're doing, it's crossing the lines or it's forgetting, so I'm holding down too many keys. And that was true at the time. And it was interesting to notice the patterns and what it kind of revealed about the wiring inside the keyboard. Kind of funny. But if you want to see the blog entry, it's up on hostilefork.com. So go check that out, and I'll put this video on it. Just wanted to put this up for posterity. Thanks for watching.